I'm in the house. Do you know where I am? I could be anywhere. I'm like the wind, baby. Yeah. Where am I?
You're behind the couch.
What? How do you know that?
I can, see your feet.
Okay, turn around. Close your eyes. No peeking. Yeah. No. Got it. All right. Hey, no peeking. No peeking. Turn around. Good. Okay, now you can look.
Okay, in case you hadn't noticed, there is a burgeoning social media phenomenon involving assorted flat Earth models and maps and experiments. This is obviously a result of recent evidence being considered all over the world, which irrefutably proves our world could not possibly be a
spinning sphere.
This is really a natural and important topic to scrutinize, since the Earth couldn't possibly be a
spinning globe.
Then there must be a means to accurately map the relative sizes of and distances between the continents. Once you've studied this possibility in depth, you'll find that there's a great deal of merit to the assorted flat Earth models. However, it's painfully obvious that we do not possess one single accurate map of the world. Short of starting in my backyard and mapping the entire world
with a ruler stick,
which might take a while, it's important to remember that the current, quote, accepted maps are primarily based on the Mercator Projection and similar maps. Quoting Wiki on the Mercator Projection,
the Mercator Projection is a cylindrical map projection presented by the Flemish geographer and cartographer Gerardus Mercator in 1569. It became a standard map projection for nautical purposes because of its ability to represent lines of constant course, known as rhumb lines or loxodromes, as straight line segments that can serve the angles with the meridians. While the linear scale is equal in all directions around any point, thus preserving the angles and the shapes of small objects, which makes the projection conformal.
Just so you know, the definition of conformal is
a map projection or mathematical mapping, preserving the correct angles between directions within small areas, though distorting distances. So the Mercator projection distorts the size of objects as the latitude increases from the equator to the poles, where the scale becomes infinite. So, for example, land masses such as Greenland and Antarctica appear much larger than they actually are relative to land masses near the equator, such as Central Africa.
It is the very definition of the Mercator projection which gives me pause to scrutinize it. I honestly would probably not have considered the flat Earth model to the extent which I have had it not been for such facts. Not limited just to the well-known, long-admitted discrepancies in our so-called accepted maps, which were designed to represent the world as a sphere by rolling the sphere around a theoretical cylinder. To arrive at conclusions such as the Mercator projection, the cartographer must first assume the Earth as a sphere prior to jotting the first segment of the prime meridian, if that's where he was going to start. I guess that's where you start if you're going to make a map. Who knows? Another issue I have with the Mercator projection is the logic of it. If you are looking at the Mercator projection and you start on the left side of the page, or the west of the Americas, and head west or go left, then you wind up on the right side. However, if you start from the bottom and go down or south, you obviously are not going to end up on the North Pole. And it appears that Mercator, and of course all mariners, even in the 1500s, knew that you could only circumnavigate this thing east to west or west to east, but certainly not north to south. And that's why I have such a problem with the Mercator projection, because it seems even way back then, 500 years ago, people knew that north to south circumnavigation is impossible. If you are looking at the Mercator projection and you start on the northern or top of the page and go due north, then where would you end up? If it's a sphere, then you would, if by going straight up north, you would end up hitting the North Pole and coming back down south. But it seems to me that the Mercator projection proves the Earth as a plane, not a sphere. But I can't think of any logical way to describe what would occur if you went due north, wound up at the North Pole, and kept straight to that line. They would argue that it would just be a curved line, but doesn't make any sense. You'd be on the other side of the world because the areas at the top and bottom of the map are allegedly stretched out to infinity. So the very bottom portion and the very top portion of the map are essentially all the same point in the globe Earth model. And if that's the case, then the polar areas would be extremely tiny. So there would be a shortcut by simply hitting the pole, and you could hit any area in that hemisphere very quickly, and most airplane flights avoid the poles like the plague. Of course, you can take a guided tour flight around the Arctic and Antarctic, but especially in the Antarctic, most people are not going to be looking for flat Earth clues. Most people totally assume the Earth as a globe, and so just by visiting Antarctica doesn't mean that it's a polar region on the bottom of a sphere. It seems far more logical that the South Polar region is encompassing the entire world. It's not just a tiny little point on the bottom of a sphere. So quoting Wiki again,
the history of California can be divided into the Native American period, obviously, European exploration period from 1542 to 1769, and the Spanish colonial period, 1769 to 1821, and the Mexican period, 1821 to 1848. Finally, the United States statehood, obviously, which continues to this present day.
Some of you may have heard of California, maybe not. So according to the accepted history, California was first set foot upon by Spanish explorers beginning in around 1542, lasting until 1769. So apparently the mainstream narrative asserts that it took explorers well over 100 years to completely explore and document the vast area known as modern-day California. California was the name given to a mythical island populated only by beautiful Amazon warrior chicks and depicted in Greek myths. In exploring Baja California, the earliest explorers thought the Baja California Peninsula was actually an island and applied the name California to it. Were there a bunch of beautiful Amazon warrior chicks there or something? At any rate, mapmakers started using the name California to label the unexplored territory in the North American West Coast. Take a look at the 1562 map of the Americas, which applied the name California for the first time. I also find it very interesting that European rumors persisted well into the mid to late 1500s, which alleged California to be an island as opposed to the western coast of the North American continent, with the southernmost tip of the area being an island as opposed to the peninsula, which it actually is. I find it fascinating also that the Flemish, or modern-day Belgian, certainly part of Europe, but the Flemish Gerardus Mercator knew exactly what the entire United States looked like, even back then, 1569, and mapped it so perfectly that we still use the Mercator projections in our modern technical age to base all of our maps. Keep in mind, this was during a period when California was still very much a mystery and was apparently still being confused with an island, or at least the California Peninsula, which is, part of South America or part of Mexico, Central America. They thought that was an island. most of Europe. There were rumors persisting well beyond the 1560s that it was an island, not a peninsula, so they didn't know diddly squat. Quoting Wiki again, the first European to explore the California coast was Juan Rodrigues Cabrillo, Portuguese Yayo Rodrigues Cabrillo, working for Spain. He died in California, and his expedition found no wealth, no advanced Indian civilization, no apparent agriculture, and no Northwest Passage. California was of little further interest. They depicted the Indians, or Native Americans, as living at a bare subsistence level, typically located in small rancherias of extended family groups of 100 to 150 people. They had no apparent agriculture, no domesticated animals except dogs, no pottery, and their only tools were made out of wood, leather, woven baskets, and netting, stones and horns, branches and mud. Some dwellings were built by digging into the ground 2 to 3 feet and then building a brush shelter on top covered with animal skin, tules, and or mud. In 1565, the Spanish developed a trading route where they took gold and silver from the Americas and traded it for goods and spices from China and other Asian areas. The Spanish set up their main base in the Philippines. The trade with Mexico involved using annual passage of Manila galleons. The eastbound galleons first went north about 40 degrees latitude. I guess this is coming from the Philippines. So they went about 40 degrees north in latitude, and then turning east, they could use the westerly trade winds and currents. These galleons, after crossing most of the Pacific Ocean, would arrive off the California coast from 60 to over 120 days later, somewhere near the Cape Mendocino, about 300 miles north of San Francisco, at about 40 degrees north latitude. Then they could turn down south and head down the coast, utilizing the available winds and the south-flowing California current. After sailing about 1,500 miles south, they eventually reached their home port in Mexico. San Francisco Bay actually escaped discovery for 200 years until it was finally discovered by land exploration in 1769. Looking into the history of our world gives me ample reason to pause and scrutinize most of the assertions held by modern scientists, geographers, and cartographers, etc., which survive to this day as absolute facts, and none of the antiquated, often misguided hypothetical theories ever seemed to be wrong or even questioned, even when most of what they were purporting was jam-packed with best guesses, wild guesses, and even plain conjecture, limited only to their imagination and relative ability to assert their imaginings as factual or even sometimes theoretically improbable, which is funny, amusing. For example, changing gears a bit, let's read a bit of Newton's Principia from 1685, just for and giggles. So this is definition 5, centripetal force from the Principia.
A centripetal force is that by which bodies are drawn or impelled or any way tend towards a point as to a center. Of this sort is gravity, by which bodies tend to the center of the earth's magnetism, by which iron tends to the lodestone, and that force, whatever it is, by which the planets are perpetually drawn aside from the rectilinear motions, which otherwise they would pursue, and made to revolve in curvilinear orbits. A stone whirled about in a sling endeavors to recede from the hand that turns it, and by that endeavor distends the sling, and with so much the greater force, as it is revolved with the greater velocity, and as soon as it is ever let go, flies away.
Genius, that Newton.
That force which opposes itself to this endeavor, and by which the sling perpetually draws back the stone towards the hand, and retains it in its orbit, because it is directed to the hand as the center of the orbit, I call the centripetal force. And the same thing is to be understood of all bodies revolved in any orbits. They all endeavor to recede from the centers of their orbits, and were it not for the opposition of a contrary force which restrains them to and detains them in their orbits, which I therefore call centripetal, would tie off in right lines with an uniform motion. A projectile, if it was not for the force of gravity, would not deviate towards the Earth, but would go off from it in a right line, and that with an uniform motion. If the resistance of the air was taken away, it is by gravity that it's drawn aside perpetually from its rectilinear.
By the way, rectilinear is just a fancy way of saying straight line or moving in straight lines.
So it is by its gravity that it is drawn aside perpetually from its rectilinear course and made to deviate towards the Earth, more or less according to the force of its gravity and the velocity of its motion. The less its gravity is for the quantity of its matter, or the greater the velocity with which it is projected, the less it will deviate from a rectilinear course, and the further it will go. If a lead ball projected from the top of a mountain by the force of gunpowder with a given velocity, and in a direction parallel to the horizon, is carried in a curved line into the distance of 2 miles before it falls to the ground. The same if the resistance of the air were taken away. With a double or decuple velocity, it would fly twice or 10 times as far, respectively. And by increasing the velocity, we may at pleasure increase the distance to which it might be projected and diminish the curvature of the line, which it might describe till at last it should fall at the distance of 10, 30, or 90 degrees, or even might go quite round the whole Earth before it falls, or lastly, so that it might never fall to the Earth, but go forward into the celestial spaces and proceed in its motion to infinity. And after the same manner, a projectile by the force of gravity may be made to revolve in an orbit and go round the whole Earth, the moon also, either by the force of gravity if it is endued with gravity, or by any other force that impels it towards the Earth, may be perpetually drawn aside towards the Earth, out of the rectilinear way, which by its innate force would pursue, and would be made to revolve in the orbit which it now describes. Nor could the moon without some such force be retained in its orbit. If this force was too small, it would not sufficiently turn the moon out of rectilinear course. If it was too great, it would turn it too much, and draw down the moon from its orbit towards the Earth. It is necessary that the force be of a just quantity, and it belongs to the mathematicians to find the force that may serve exactly to retain a body in a given orbit, with a given velocity, and vice versa, to determine the curvilinear way into which a body projected from a given place with a given velocity may be made to deviate from its natural rectilinear way by means of a given force. The quantity of any centripetal force may be considered as of 3 kinds: absolute, accelerative, and motive.
Now, for a force that, according to modern globe earthers, doesn't exist, Newton certainly mentions centripetal force dozens of times in the first 20 pages of the book upon which modern physics is based, the Principia. So, when we look back at history, oftentimes we're looking back on a phase in the human experience when many fundamental forces, specifically but not limited to electromagnetism, were simply unheard of. If you're not familiar with Professor Eric Laithwaite, his story is extremely interesting. He was a really brilliant electrical engineer. Without going into too much detail here, Professor Laithwaite was very famous in Europe, an accomplished electrical engineer responsible for breakthrough inventions like the linear motor and magnetic levitation trains. He did a great job in describing how we see some natural physical forces reflection and believe that reflection of the natural physical force to be some other mysterious physical force, least of which I would imagine he's referring to would be electromagnetism.
All that's something different, precession. And I shall have a lot more to say about precession in a few minutes. The Jabberwock was a monster with many heads. It was as if it was, for me, a representative of the way we divide our science into physics, chemistry, biology, and then we take one of those, like physics, and we divide it into heat, light, sound, electricity, and magnetism, then we subdivide that, and so on. Now, some of these heads of the Jabberwock are really laws of physics, I suppose, for me, and some of them look into mirrors and see their own reflections, and they then think there are more of their kind than there really are. The same can probably, from an engineering point of view, be said about the so-called fundamental particles. They try to coexist with each other. Now, the idea of science, in rather perhaps the profession of science, as a monster, is not a new one. Martin Gardner, my favorite author, put it in a neat way in a chapter on the fall of parity. And we talked about parity last time and said that parity was to do with the universe as a whole being handed, having a preference for left or right-handedness without saying which. And Martin Gardner wrote this: not one of the three experiments that first toppled parity would have been performed at the time it was performed if Li and Yang had not told the experimentalists what to do.
After being introduced to gyroscopes, he became fascinated with them and did all sorts of experiments, proposing there is more to spinning discs or gyroscopes than meets the eye. For example, if you take a heavy metal wheel on a heavy metal stick with the stick as the axis, if the wheel and axis weigh about 50 pounds, it's nearly impossible for even a strong person to lift the weight with one hand by the axis and hold the axis parallel to the ground, again with one hand, due to the weight of the objects and the lack of leverage at that position. It's impossible to do. However, if you spin the wheel at high velocities, it somehow appears to lose most of its weight. And the same man that struggled to hold the weight up by the axis with one hand can swing it around his body and over his head with ease with one hand. To me, this proves that, quote, gravity is not what we've been led to believe, and by simply spinning an object around in a perfect axis, the object will defy the so-called laws of physics. Laithwaite was ridiculed for such postulations and was discredited by the scientific community as a heretic of science simply for making such keen and correct observations. To me, this is a tragedy, as repeatable experimental observations which defy the so-called laws of physics are crucial for scientific understanding of the natural world and should be extremely interesting to any scientist or engineer. Unfortunately, since such repeatable scientific observations discredit the
conventional paradigm,
they are always ridiculed and discredited, often causing the true geniuses of the world to remove themselves from further experimentation and obliterate the chances of making inevitable critical discoveries and inventions that could benefit everyone.
We go to this machine, which has little buckets around the outside so that I can blow air on them and get it spinning to a quite high speed. Something like 5,000 revs a minute. Don't be alarmed by the noise. When we get this 8-pound wheel up to speed, I shall take a pin out there to allow it to flop like this, and then we shall do experiment number 1, which is to search for centrifugal force. If I bring out the gyro to that position, it is free to topple over. I shall need, in fact, a little weight to hold it down. Of course, in any other position, it's all right. It's only when the offset mass comes out there that it weighs over like that. Now, we'll spin this up, and then I'll take the weight off and ask Mr. Coates to catch the gyro as it falls. Now, if you'll come around there and ready to catch it when I lift the weight, next time round it's coming off. He cheated again, says the man in the gallery. Did he really? Yes, he pushed the aluminium back a bit. All right, he'll pull it forward a bit. More than a bit. Pull it forward a lot. The whole of the tower is now well outside the end of the bench. And if you want me to prove it, I'll show you what happens when the wheel is stationary. Again, it doesn't require much catching, you see. It's gentle as a lamb. Now we'll put the pin back in, and we'll see by how much it overbalances. Well, a lot, obviously. How much? That much? Oh, a lot more than that. That much? More than that. That's it. That much. Over 2 kilograms. Out of balance. And if that looks a ridiculous thing to do, I'm going to spin it up again and then turn it upside down. Yep. quite a brute to take upside down. Up to the marks. There we are.
I too am fascinated by gyroscopes, and for a few reasons, least of which is the concept of rotational motion causing objects to essentially defy physical laws, meaning physical laws are not really laws whatsoever. If the mass of the spherical Earth is truly what causes objects to fall to the ground, spinning the damn thing should not make any difference, should it? This makes me wonder about Newton's postulations of firing a musket ball into orbit from a mountaintop if the forces and conditions were right, but I wonder if Newton had in mind a musket ball or a rifled round. If you're not familiar, the main difference between a rifle round and a simple musket ball is the barrel of a rifle has what are essentially a spiral or helix groove etched into the inside of the barrel, causing the projectile to spin at high velocities. Furthermore, instead of a ball or sphere-shaped bullet, rifled rounds use an elongated round, sort of like a football, which would spin around a perfect axis, which ultimately increases the range, power, and accuracy of the rifle. So, quoting Wiki,
the origins of rifling are difficult to trace, but some of the earliest practical experiments seem to have occurred in Europe during the 15th century. Archers had long realized that a twist added to the tail feathers of their arrows gave them greater accuracy. Early muskets produced large quantities of smoke and soot, which had to be cleaned from the action and bore of the musket very frequently, either through the action of repeated bore scrubbing or a deliberate attempt to create soot grooves that would allow for more shots to be fired from the firearm before having to clean it. This might have also led to a perceived increase in accuracy, although no one knows for sure. True rifling dates from the mid-15th century, citation needed on that one, although military commanders preferred smooth bore weapons for infantry use because rifles were much more prone to problems due to powder fouling the barrel and because they took longer to reload and fire than muskets.
Citation also needed on that one. That's the problem with Wiki. Sometimes you just read crap that might just be conjecture, but still interesting source. Continuing with Wiki,
rifles were created as an improvement in the accuracy of smoothbore muskets. In the early 18th century, Benjamin Robbins, an English mathematician, realized that an elongated bullet would retain the momentum and kinetic energy of a musket ball, but would slice through the air with greater ease.
So, it's fairly safe to deduce that rifled rounds don't perform better just as some coincidence or strictly due to improved aerodynamics, but if you spin a circular type object at high velocities around a perfect axis at the center of the circle, the object appears to negate much of the so-called gravity exerted upon it, and will travel much greater distances with better accuracy than its spherical predecessor, the musket ball. If you've ever thrown a football or watched a football game even, it's pretty common knowledge that a perfectly thrown spiral will glide through the air often greater than 50, 60, 70, even upwards of that yards, just by the flick of the wrist of, say, Dan Marino. Never really understood how he did that, but it's extremely difficult to throw a football that far if it's not, a perfect spiral. Similarly, it's difficult to weigh a football while it's in the air. Fortunately, Professor Laithwaite indeed did experiments with gyros and their effect on measurable weight on the ground, finding the spinning wheel to actually negate the so-called forces of gravity under certain conditions. It's pretty obvious now, as we consider the world as a stationary plane, not a spinning sphere, that a spinning wheel could not negate the overwhelming force of gravity as a warping of space-time simply by spinning on an axis, for crying out loud. I believe Laithwaite was definitely onto something, and given his background and experience with electromagnetism, I feel that the scientific community could have uncovered innumerable secrets of the natural laws had they just given Laithwaite's observations and theories a fair shake. If we consider the forces responsible for what goes up must come down as something other than the mass of the Earth warping space-time, then an object losing weight due to spinning doesn't become so preposterous and doesn't break any laws of physics. Just as a side note, if you ever need to go on a diet, try spinning yourself around at high velocities. Might be a temporary fix. But anyways, if a law of physics can be broken, then it isn't much of a law, now is it? Calling something a law out of misunderstanding the natural world does not actually make that idea a law. So if the observations and postulations of Newton can be easily debunked by a simple spinning wheel, or the Earth as viewed from 40 miles up possessing no discernible curvature, or airplanes making east to west trips just as quickly as identical west to east trips when the Earth is supposedly
spinning 1,000 miles per hour towards the east near the equator,
then what other laws of physics or assumptions of cartographers can we rely on? Especially so when such so-called technologies are literally hundreds of years old, predating the first airplane, predating electromagnetic schematics and understanding, definitely predating even the first football, which wasn't even introduced until 1870. So, looking at the Mercator projection map and comparing that with the Gleasons flat Earth map, I see some problems. I honestly don't think we have any truly accurate maps, and for a few reasons. First of all, the Gleasons map resembles the Mercator projection map very closely, and I find that as problematic. Since I've already given the method used to render the Mercator projection, a method which causes most of the continents to appear completely skewed and distorted in terms of relative distances and sizes, I wanted to juxtapose the Mercator projection continents over the Gleasons standard map just to see what types of deformations were necessary to arrive at the Gleasons conclusion. In all honesty, the Gleasons map doesn't appear to represent the land masses all that well, according to the theory. It appears that some of it is indeed pretty accurate though, but Australia looks pretty good, and even this position really isn't solid as far as I'm concerned, if I'm being honest. I was expecting to see the distances below the equator to be stretched out laterally, or from east to west around that curve, but it appears that the Gleason map really just sort of rearranged and skewed the continents a little bit and rather haphazardly. The deformation of Australia, however, appears to be more in line with what I would have expected to see on all of the land masses which were, well below the equator or in the southern hemisphere, or should I say the outermost area of the flat Earth map. Furthermore, most of the meridian lines, that's the north to south lines, appear to be in accordance with the meridian lines on the Mercator projection, which does indeed make sense to me. On the other hand, if you look at China, in order to get that to fit, it seems like the meridian lines, in Eurasia, which is China and Russia, on the Mercator projection are pretty well out of line with the meridian lines in Eurasia on the Gleasons map, in order to get that, landmass to fit. I don't think the Gleasons map was created to intentionally mislead flat earthers, but I don't think it's an entirely accurate map for the reasons I've just described. Of course, I'm no cartographer, but it seems like everything south of the equator should be squished down in from north to south and outstretched from east to west. Furthermore, it might be prudent to consider squishing the land masses north of the equator east to west and outstretching them north to south. Like doing the opposite in the northern hemisphere than you would in the southern. Now, it seems like if we were to take the relative distances on the Mercator projection and apply such a process of squishing and stretching the land masses, depending on their position relative to the equator, that might get you something close to what the actual world looks like. I believe that by applying such changes to the Mercator projection, we could end up with something very close to the truth. Now again, I'm no cartographer, so to me, simply submitting the idea to the community should be a good start and a decent way to get people with experience in making maps to entertain the idea. Again, I believe the amount of squishing and stretching of Australia well into the outer semiplane, and yes, I'm going to say outer semiplane instead of southern hemisphere, and inner semiplane instead of northern hemisphere, from this point forward, although I understand it is a bit of a misnomer. I just hate the word hemisphere when talking about the world. But it seems like that degree of squishing and stretching on Australia should be apparent across the landmasses in the outer semiplane, and the opposite of that, might be necessary for the landmasses in the inner semiplane. I also find it interesting that the 1562 map of America shown here has the southern tip of South America, or outer America, butting up against the Antarctic, or outermost ring of the outer semiplane. Another piece of this flat Earth puzzle certainly involves radio waves and radio towers. I touched on this topic briefly in a previous video, but I wanted to expand on this just a little bit more in depth. If you've never hung out with us on the weekly Globebusters show with Jaronism and Bob Nodell, then you're missing out on a lot. We have a lot of fun, and it's a great show. Bob's a regular co-host on the show, and he actually has a great deal of experience with radio, satellite signals, and we've had guests on the show recently with similar experience, and they both insist and agree that the distances of radio shots exceeding 60 miles, even exceeding 100 miles, prove that the world couldn't possibly be a sphere of any sort. This jives very well with the observations of distant lighthouses, which can be seen with the naked eye for over 60 and 70 miles. You must realize that if the world was any sort of sphere, such radio shots and distant lighthouses would be impossible to receive with your eye or with a radio receiver, as the Earth or ocean itself should completely obscure the visible light or visible line of sight by hundreds or even thousands of feet. RF waves as well as visible range light waves simply cannot travel through the solid ground or even the ocean and then be seen by an eyeball or even picked up by a radio receiver. There's no possible way for a 150-foot radio tower to send and receive RF waves to another similar tower over 50 or 60 or even 110 miles away. As I've stated before, there's no reason to believe the generic little plastic and metal dish attached to the side of your house is communicating with a satellite zipping around in the magnetosphere or thermosphere, and there's no evidence to support that theory. You can manually position a satellite dish using a bit of trial and error or deductive reasoning. Radio frequencies attenuate or basically fizzle into the background noise at distances far less than the distances purported by NASA and others responsible for launching and tracking and maintaining the orbit of satellites. It seems fairly obvious that satellites in space are completely unnecessary, and the technologies needed for modern luxuries such as GPS, cellular phones, and the internet are totally doable without the use of satellites. Seeing how the US military has been using what appear to be exactly identical to satellite dishes and cell phone towers since the early 1950s, when exactly 0.0 satellites were purported to be hauling balls around space, instantly sending and receiving information across hundreds or even thousands of miles without any sort of delay, then why in the world would they spend trillions of dollars over the decades on space programs if satellites are not necessary? Why would the totally chintzy world powers run high bandwidth cables across the pond from the United States to Europe if satellites were all around the world? Why is it that we lose cell coverage when driving through dead zones, which always tend to correspond with areas that are very distant from the nearest tower? When experienced electrical engineers and radio experts are telling you that it's impossible for certain long-range shots to occur on a spherical Earth, and there's no possible way the RF signals from a satellite several hundred miles away up in space could ever possibly deliver a strong enough signal over those sorts of distances, then why in the world would you continue believing that's what's actually happening when you flick on your dish TV or punch in an address on your GPS? The military has been using radio triangulation as well as so-called geostationary weather balloons since long before the first satellite was ever launched into space. The world is permeated with electromagnetic flux lines and even plasma tubes created by ionized gases in the lower magnetosphere, creating a fairly effective non-physical barrier around the top of our world up in the sky. The world certainly does not need to be a spinning sphere to generate such magnetic fields. If you go with the flat Earth theory for a bit and consider the heavenly bodies, including the sun, moon, and stars, are spinning around the astral plane concentric with the North Pole, I don't think it's a far leap to make a hypothesis that the magma beneath us could also be compelled to spin beneath our feet, which could be causal of such magnetic fields. Since it's fairly safe to assume that there are several layers of magnetic fields emitted from the Earth and traveling in great curves up to space, then around down to the outside, or the southern area, or outer semiplane, then there could very possibly be similar electromagnetic fields deep beneath the ground, running in a similar pattern to those above our heads. It's almost as if we all reside within an electromagnetic donut or toroidal field of sorts. It's also quite possible that such phenomena are responsible for all sorts of so-called physical laws, including gravity, electromagnetism, friction, inertia, visible light waves, or even physical matter itself. Who knows? I suppose it's possible, with all this in mind, that if we were to travel beyond the outer semiplane, the physical laws that we're comfortable with and accustomed to could conceivably begin to break down. Perhaps our world is the only one of its kind, or maybe there are other similar worlds very nearby on the physical plane here on the ground. I think if we ever get the Antarctic and Arctic treaties abolished, we should be prepared to spend a great deal of time experimenting with a physical reality that is not necessarily beholden to the exact physical laws that we're familiar with. I think it's a lot of fun to look at the etymology of common words that we take for granted but never really examine. Here's a fun one, Einstein. This is from Ancestry.com. Einstein is a German and Jewish, Ashkenazic, habitational name from any various places named with Middle High German derivative of Einsteinian, to enclose or surround with stone. In the unsettled social climate of the Middle Ages, even relatively minor settlements were commonly surrounded with stone walls as a defense against attack. Jewish, Ashkenazic, ornamental name composed of German Ein, one, plus Stein, stone. So in other words, the surname Einstein could loosely be translated to flat earth model. What do you know? Another one is firmament, and I've mentioned this one before, and I just wanted to recap it quickly, but from Old French firmament, or directly from Latin firmamentum. Firmament, literally a support, a strengthening, from firmus, strong, steadfast, enduring. See firm, adjective, used in late Latin in the Vulgate to translate Greek stereoma, firm or solid structure, which translated Hebrew rakia, a word used of both the vault of the sky and the floor of the earth in the Old Testament, probably literally expanse from rakah, to spread out, but in Syriac meaning to make firm or solid, hence the erroneous translation related to the firmament or firmamental. Not to harp on this one subject, but biblical scholars pointing to the word firmament being indicative of a physical solid dome in the sky is a misnomer. It's a misunderstanding of a biblical concept which was originally describing a simple expanse, ultimately mistranslated to describe a solid physical structure. Furthermore, in Isaiah 40:22, the English translation reads, "It is he that sits on the circle of the earth, and the inhabitants thereof are as grasshoppers, that stretches out the heavens as a curtain, and spreads them out as a tent to dwell in." Now, if you study the etymology of the words originally used in that part of the Old Testament, the word used for curtain can also be used to describe pulverizing to a fine powder, or can denote a thin veil. So the original intent of that passage could have been translated a number of different ways, and still would have been technically a correct translation, and it didn't necessarily describe a literal physical tent or curtain above our heads. It's almost as if the passage describes the astral plane as a thin veil. I think it's easy to misinterpret biblical intentions, and it's certainly very easy to misunderstand such mistranslations. Distant stars appear to get lower and lower towards the horizon, which gives the illusion of a dome-like shape, but that is very logically explained as being caused by simply perspective and how we view the world. Objects above us will appear to get lower and lower towards the ground or towards the horizon as their lateral distance from you, the observer, is increased. Even though the stars directly above your head are probably on the same plane as the stars right near the ground or near the horizon off in the distance, the reason this can get sort of confusing to us people is because we tend to confuse the vanishing point here on the ground with the vanishing point on the astral plane. We can only see a few miles in any direction parallel to the ground, here on Earth due to perspective. On the other hand, we could see much further into the distance on the far removed astral plane, but unfortunately the vanishing point here on the ground will obscure your view of any stars that stray beyond that point on the astral plane. So we confuse distances on the astral plane with distances here on the ground, which causes a fundamental flaw in how we view the world. And only by thinking this through can you really understand it. Some flat earthers will purport that if you travel to the far south and view the southern stars disappearing beneath the horizon, facing south in the south, this means that those stars are actually going beneath the physical plane. This is, of course, preposterous, as the stars would appear to be increasing their distance from the observer laterally on the astral plane as the ether in the firmament rotates, and would therefore appear to drop lower and lower on the horizon as that distance from you, the observer, is increased. We see the sun rise and set every day, but that doesn't mean the sun has dipped beneath the physical plane whatsoever. Again, we only have the ability to see a small finite distance here on the ground due to perspective and, of course, atmospheric refraction. But our observations of the astral plane are not bound to such strict visible distances due to the astral plane itself, but instead the distance we can see towards the astral plane is bound to the visible distances here on the ground, if that makes any sense. So in other words, the vanishing point here on the ground obscures the far distant stars on the astral plane. This gives us a false illusion that the distant stars are adhering to a dome shape, but instead it's very logical to assert that they are fixed to a very similar, if not the same, astral plane, and only our vision is skewed. And the more distant stars are obscured by the ground horizon line, but are not actually anywhere near the ground horizon line. Hopefully I can whip up a graphic or two that sort of demonstrates this, as it is sort of hard to explain, but very simple to wrap your head around if you do take the time to think about it. So another one, planet from Etymology Online, late Old English planete from Old French planete, or modern French planete. I don't speak French and I don't speak Old English, sorry. But from late Latin, planeta, from Greek planetus, from astraries, planetae, wandering stars, from planasthai, to wander, of unknown origin, possibly from pi, pele, flat, to spread, on notion of spread out. So called because they have apparent motion, unlike the fixed stars. Originally also including the moon and sun, modern scientific sense of the planet being a world that orbits a star is from the 1630s. So the word planet appears to indicate a flat surface at its roots, and could also be used to describe the wandering stars. And it wasn't until the late 1600s, really not that long ago, when people began associating the word planet, or the etymological roots of the word, with a world orbiting a star. And finally, just looking at the use of common words such as water in the original Old Testament is extremely daunting, as such a simple common word as water can have so many different meanings in the original Hebrew, depending on the context and intent of the author or even the translator. Okay, so we're looking at Strong's 4325, mayim. Mayim is waters or water. It's a masculine noun. It's pronounced mahim. Okay, so just scrolling down through some of this, you can look at the NAS exhaustive concordance, word origins, water's water, obviously, but the NASB translations, flood, loins, pool, water, watering, waterless, waters, and even more, uses of the same word. Just to kind of scroll through these and read some of them. You've got, okay, here we go. So 1A, water of a spring or well. And you've got water of a river, like the Nile, water of the sea, water of the flood, subterranean, in clouds of rain, of dew, primeval deep, with proper names of location, denote springs, streams, or seas belonging to near such places. Special uses are water of the feet equals urine, compare, water of a dunghill, imprisonment, because drunken imprisonment is water of a dunghill, water which is distress, because drunk in imprisonment. Among figurative uses are of distress, of outbursting force, of what is impetuous, violent, overwhelming, of transitoriness, of refreshment, of reckless bloodshed, of outpoured wrath, of abundant justice, masculine, of outpoured feelings, just tons of different uses for the word water. It's got waste, wasting, watering, course, dual of a primitive noun but used in a singular sense, water, figuratively juice, by euphemism, urine, semen, piss, wasting, water. Lots of different ways that you could interpret such things as, waters from the waters. I don't know. I don't speak Hebrew. But to put this in perspective so that we can understand it in a modern sense, tonality and context give us clues as to the intent behind a word. And growing up as a native English speaker, you sort of get the hang of it after a while. So, for example, the word killer can mean someone who kills things, or it can mean something great, depending on the tone and the context. So, like, the police caught a killer, or that is one killer steak. So if someone came along 2,000 years from now and read a text message from one modern American to another, they would swear they were crazy or stupid for suggesting that a slab of a cow's ass, which has been sliced into a juicy morsel and seared to perfection, could somehow jump off the plate and start murdering people. You and I would automatically know the person was speaking figuratively, as a steak could no more kill someone than a plastic spork could. Unless you get creative, I guess, but this is what I mean when I say the original intentions behind biblical words or phrases can be skewed by even honest translation, even if the translator has the best intentions and a very firm grasp of the literal language. I'm not claiming that the biblical intentions behind divide the waters from the waters is a poor translation, as I simply don't know enough about ancient Hebrew to make the call. But according to what I'm seeing, the biblical intent behind dividing the waters from the waters could be translated as something completely different, even dividing the piss from the loins, or dividing the overwhelming violence from outpoured feelings. Now I realize that's, going a bit far, and I'm not trying to be vulgar, just looking into things and trying to understand how we've arrived at certain conclusions which are asserted to us as factual, but when you really do take the time to dissect the etymology or the origins of these so-called laws or facts, the fundamental basis for them is often pretty flimsy.